I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks, this and that. Spitting slow, spitting fast. I could roast, I could gas. Think I'm okay at last, but I don't know if that can erase all the past. And the pettiness, a reflection of the emptiness. Hilarious, you think you're worth my time, you're delirious. Mysterious, because you hide behind a fake exterior. Inferior, you know I'll always be a bit superior. Get off of me, this ain't no humble brag. I want you to hear words, you can say them back. I want you to feel free from the chains at last, and to believe in
Our cosmic backyard, the solar system. The vast expanse of space that we call home is filled with wonders and mysteries, waiting to be explored. Our solar system is a fascinating and diverse place. It consists of the Sun, 8 planets, their moons, and countless smaller objects like asteroids and comets, all bound together by gravity. At its heart lies the Sun, a giant ball of hot gas that provides light and warmth to all the planets orbiting it. The Sun's immense gravity holds the solar system together, and its energy drives the climate and weather on Earth. Let's take a quick tour of our celestial companions. Each planet has its own unique characteristics and features that make it special. Closest to the Sun is Mercury, a small rocky planet with a scorching hot surface. Despite its proximity to the Sun, Mercury has no atmosphere to retain heat, leading to extreme temperature fluctuations. Next comes Venus, shrouded in thick clouds that trap heat, making it the hottest planet in our solar system. Its surface is a hostile environment with temperatures hot enough to melt lead and crushing atmospheric pressure. Then there's Earth, our home, a vibrant planet teeming with life. Earth is the only planet known to support life, thanks to its perfect distance from the Sun, liquid water, and protective atmosphere. Mars, the red planet, is a cold, dusty world with evidence of a watery past. Scientists are particularly interested in Mars because it may have once harbored life, and future missions aim to uncover its secrets. Further out, we encounter the gas giants. Jupiter, the largest planet, with its swirling storms. Jupiter's Great Red Spot is a massive storm that has been raging for centuries, and its many moons include some of the most intriguing objects in the solar system. Saturn, known for its magnificent rings. These rings are made of ice and rock, and they are one of the most stunning features in the solar system. Saturn also has a diverse collection of moons, including Titan, which has a thick atmosphere and lakes of liquid methane. Uranus, a blue-green ice giant. Uranus is unique because it rotates on its side, possibly due to a massive collision in its past. Its atmosphere is composed mainly of hydrogen, helium, and methane, giving it a distinctive blue-green color. And Neptune, the farthest planet from the Sun, with its supersonic winds. Neptune is known for its deep blue color and its dynamic atmosphere, which includes the fastest winds in the solar system. Each planet in our solar system is unique, with its own story to tell. From the scorching surface of Mercury to the icy winds of Neptune, our solar system is a diverse and dynamic place. But what about the stars themselves? Beyond our solar system, the universe is filled with billions of stars, each with its own planets and potential for life. Let's explore the incredible life cycle of these celestial giants. Stars are born in vast clouds of gas and dust, live for millions to billions of years, and end their lives in spectacular explosions called supernovae. These events create the elements that make up planets and life itself, continuing the cycle of cosmic creation. Section 4. Stellar Nurseries and Cosmic Furnaces, the Life Cycle of Stars. Stars are the brilliant beacons of the universe, illuminating the vast expanse of space. But have you ever wondered how these celestial giants come into existence and what happens to them over their lifetimes? Let's embark on a journey through the fascinating life cycle of stars. Stars are born in vast clouds of gas and dust called nebulae. These nebulae are often the remnants of previous stars that have exploded in supernovae, scattering their material across space. Within these nebulae, regions of higher density begin to form, setting the stage for star birth. Gravity pulls the gas and dust together, causing the cloud to collapse. As the cloud contracts, it begins to spin, and the material at the center starts to heat up. This process can take millions of years, but eventually the core becomes hot and dense enough to form a protostar. As the cloud collapses, it heats up, forming a protostar. This early stage of a star's life is marked by intense activity as the protostar continues to gather mass from its surroundings. The temperature and pressure in the core rise steadily, preparing for the next critical phase. If the protostar gathers enough mass, the temperature and pressure at its core become high enough to ignite nuclear fusion. This is the moment when a star is truly born. Nuclear fusion is the process where hydrogen atoms fuse together to form helium, releasing enormous amounts of energy in the form of light and heat. Hydrogen atoms fuse together to form helium, releasing enormous amounts of energy. This energy radiates outward, balancing the gravitational forces pulling the star inward. The star enters a stable phase known as the main sequence, where it will spend the majority of its life. The protostar becomes a star. It shines brightly, a new beacon in the cosmos. The main sequence phase can last for millions, billions, or even trillions of years, depending on the star's mass. During this time, the star continuously fuses hydrogen into helium in its core. Stars spend most of their lives fusing hydrogen into helium in their cores. This process is incredibly efficient, allowing stars to shine for vast periods. The energy produced in the core travels outward, eventually reaching the star's surface and radiating into space. This process can last for millions, billions, or even trillions of years, depending on the star's mass. Massive stars burn through their fuel much more quickly than smaller stars, leading to shorter lifespans. In contrast, smaller stars like red dwarfs can burn for trillions of years. Massive stars burn hotter and brighter but have shorter lifespans than smaller stars. These giants of the cosmos live fast and die young, often ending their lives in spectacular supernova explosions. Smaller stars, on the other hand, lead longer, more stable lives. Eventually, a star will exhaust the hydrogen fuel in its core. When this happens, the star must find new sources of fuel or face its end. The core contracts and heats up, while the outer layers expand and cool, leading to dramatic changes in the star's appearance and behavior. What happens next depends on the star's mass. Smaller stars, like our Sun, will expand into red giants before shedding their outer layers. This process creates beautiful planetary nebulae, leaving behind a dense core called a white dwarf. White dwarfs are incredibly dense and slowly cool over billions of years. Small stars like our Sun will expand into red giants before shedding their outer layers, leaving behind a dense core called a white dwarf. These remnants are the final stages of a star's life, slowly fading away over time. Massive stars, however, have a much more dramatic end. Massive stars, on the other hand, will experience a much more dramatic fate. When they exhaust their fuel, their cores collapse under gravity, leading to a supernova explosion. This cataclysmic event scatters the star's material into space, often leaving behind a neutron star or black hole. These remnants are some of the most extreme objects in the universe, continuing the cycle of stellar evolution. Section 5. Cosmic Abyss. Unveiling the secrets of black holes. When a massive star runs out of fuel, its core collapses under its own gravity. This collapse triggers a supernova explosion, one of the most powerful events in the universe. If the core is massive enough, it will continue to collapse endlessly, forming a black hole. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. They are invisible to telescopes, but we can detect their presence by their effects on nearby matter. As matter falls into a black hole, it forms a swirling disk of superheated gas called an accretion disk. This disk emits intense radiation that we can observe. Black holes are still shrouded in mystery, but they continue to fascinate and challenge our understanding of the universe. Now, let's shift our focus from these cosmic behemoths to the human endeavor to explore the cosmos.